Hey, you guys, welcome to another week of lesson. Today we're focusing on 9.2 exponential growth and decay. All right. So the vocabulary words for this lesson is compound interest, decay factor, exponential decay, exponential growth, growth factor, and apply. All right, let's go ahead and focus on today's main concept of the lesson. All right, so when we're dealing with exponential growth, in other words for this is increasing, the graph, it's increasing. So exponential growth can be molded by the function of y equals a times b to the power x, where a is greater than 0 and b is greater than 1. So the base b is the growth factor, which equals 1 plus the percent rate of the change expressed as decimal. So if we're looking here into this type of expression, the initial amount is always going to be your A. When your x is equal to 0, it's also the y-intercept. So the initial amount is A and as well your y-intercept. Just make sure those two corresponds to A. Your B is going to be basically your base, which is greater than 1, is a growth factor. The x is going to be considered your exponent in this case. So we have here a sample graph, and it's showing you that that point, that's your y-intercept. And then you have your isotope as well. B is greater than 1. So it's just giving you like an example. If you want to know a little bit further about isotopes, look over section 9.1. All right, when it comes to exponential decay, it's basically a decrease. It's decreasing. The graph looks like it's going down. Can be molded by the function of y equals a times b to the power x, where a is greater than 0 and b is greater than 0 but less than 1. So it's like a fraction, like a decimal place, but it has to be between 0 and 1. So the base B is the decay factor, which equals to 1 minus the percent rate of the change expressed as decimal. So every time you have a fraction or decimal place under your B, your core tell is an exponential decay, which is decreasing. Again, this information is the same thing as the previous slide. It's your initial amount and your y-intercept for the A, and B is the base. In this case, as a decay. All right. All right, so let's look at some questions. Let's go ahead and practice some. You are observing a bacteria population in a laboratory culture. The population doubles every 30 minutes. The function of P of X equals 500 times 2 to the power X. Models the population where X is the number of 30 minutes period since you began observing. Graph the function P of X equals 500 times 2 to the power X. Identify the y-intercept and asymptote. Okay, so if we graph this based on last section on 9.1, if we graph this, we get a graph something like this. Now, if you recall that your A, this is your A, that's your initial amount and also your y-intercept. So your y-intercept in this case is gonna be 500. That's your y-intercept. For your isotope, let's look at the graph. The graph is basically this part of the line, this part. It's going to, is going continuous all the way to a negative infinity values towards this direction, but it's never gonna be crossing the line of the isotopes on this dotted line. Let's try to put it in a different color. This dotted line means that the curve of the line is never gonna be crossing that dotted line. It's gonna get really, really, really close, but based on research of many decades by many experts, they have not determined that this is not gonna cross this line. So your isotope at this point, since it's your y-axis, it's at 0, then it's gonna be y equals 0. That's your isotope. All right. Again, this is just information from based on last lesson on 9.1. So if you're still having a little bit of trouble, go ahead and go back and review it. All right. So the function of p of x equals 500 times 2 to the power of x modes a population of bacteria in a laboratory culture you are observing, where x is the number of 30 minutes period since you began observing the bacteria. The graph of p of x is shown below. Use the graph to find p of 3, explain its meaning. All right. So again, we have something similar to the previous one from this one, because it's the same problem. Now we just need to know when it hits at 3, how much are we gonna have? So technically that 3 is gonna be your x based on this information. And we're gonna substitute it into the equation over here. So you can have p of 3 equals 500 times 2 to the power of 3. So going through your calculator, let's go ahead and start a new one. If we have a 500 times 2 to the power of 3, we get a result of 4,000. So in this case, we get 4,000, which is letter D. All right. So that's basically the bacteria that we're observing. All right. Let's go ahead and look at another main concept that we need to focus as well. Now, this is dealing more with interest, with banks and businesses. So when a bank pays an interest on both principal and interest, an account has already earned. The bank is paying a compound interest. You can use the following formula to balance of an account that earns compound interest. So this formula, we're gonna be focusing more on this formula provided to us. The A stands for the balance, the P stands for principal, which is the initial. R stands for the interest rate. N stands for the number of times interest is compounded yearly, and T is the time in years. All right, this formula was introduced to you partly in 7th or 8th grade. So it just came back to you since it's part of algebra. All right, so let's go ahead and practice some. Since 2005, the amount of money spent at restaurants in the United States has increased about 7%. So that 7% is gonna be basically your rate. So R is gonna be 7%. If we convert this into a decimal place, we move 2 decimal places back because we're dividing by 100. So we have 0.07. 1, 2, yeah. So in 2005, about 360 billion was spent at restaurants. So that's gonna be your P, your initial amount, 360 billion. If the trend continues, about how much will we spend at the restaurants in 2015? So from 2005 to 2015, there was a 10-year difference. So that's gonna be your time. Time is gonna be 10 years. In this case, the n is gonna be a 1 because we're focusing on each year, okay? It's not being compounded quarterly or monthly, it's compounded yearly. All right, so once we establish some data, we just put it into the formula here. Our P is gonna be 360. We have 1 plus 0.07 divided by 1 to the power of 1 times your time, which is 10. Which this becomes 360, 1.07 to the power of 10. And once you input this in the calculator, you're gonna get this result. You're gonna get about 708 billion billion will be spent at restaurants in 2015 if the trend continues. So basically that's all you're doing. You're just labeling the information and you plug it into the formula, which this formula, it takes a little bit of time to remember, but it's not too hard. It's not too complicated. Let's try this again. Suppose that when your friend was born, your friend parents deposit 2,000. So when they deposit it, that means it's gonna be your initial amount, which is P. So P is 2,000. In account paying 4.5 interest. So interest again is your R. Move, you have 4.5%. Convert that into a decimal. You move 2 places, the decimal places, which is 0.045. Now here it says compounded quarterly. Now you are gonna have an N, but it's gonna be by quarters. Quarters means like quarters in 4, because that's what the meaning of quart. So you're gonna have 4 quarters. What will be the account balance be after 18 years? So your time will be 18 years. And then from there, we just plug in that information into the formula. So we have P, that is 2,000 times 1 plus 0.045 divided by 4, because the N is 4, to the power of 4 times 18. All right. Once you input this in the calculator, you had 2,000 here. Let's see, we have 1 plus 0.045 divided by 4. We get 1.011. 1.011 to the power of 4 times 18, 72. So we get this expression, and once we input all of this into the calculator as well, we get a final result of the balance will be this much, which is 4,475 and 53 cents after 18 years. So that's how much a compounded quarterly you're gonna be getting as a final result, as the amount after 18 years. Let's go ahead and practice one more time. Suppose that when your friend was born, your friend parents deposit 2,000. So again, principal is 1,000. In account that is paying 4.5 interest, so your rate is 4.5%. If we convert this as a decimal place, we get 0.045. But in this case, it's compounded monthly. So whenever you're doing monthly, monthly throughout the year is going to be 12 months. What will be the account balance after 18 years? So again, your time is going to be 18. So technically, this is the same information from the previous example that we just did. Just this number was the only one changed. That was all. So again, we have our 2,000. We have 1 plus our rate is going to be 0.045 divided by 12 to the power of 12 times 18. Yes. All right. So again, we have 1 plus 0.045 divided by 12. We get 1.003. So you have 2,000 times 1.003 to the power of, let's see, 12 times 18. We get 216 to the power 216. Once we calculate this, we get our final result as 4,489 and 1 cent after 18 years. So in this case, our answer is going to be letter C. Okay. Now this one was closely related to this one as well. There were just a couple of numbers being changed. But again, you're just using the formula. First thing, write it down and then plug it into the formula. And from there, just use the calculator and you should be okay. Should be good. All right, so here they're saying the value of a function decreases by a factor of 0.3 with every unit increases in x. When x is 0, the value of the function is going to be at 12. Write an exponential function in the form as y of fx equals a times b to the power of x to describe the situation. All right, so here we just need to write down the function. We don't need to solve for anything. We just need to put it as an equation, basically. So if we start off with f of x, our value of the function, 12, this is your initial 12. So since you're going to start with 12, that's going to be your a. Whenever there's a factor, it means a multiplication. It means that you're going to multiply this by 0.3. It's being decreased because it's a decimal place. If you go back to this information, remember I told you whenever you're dealing with, like right here, whenever you're dealing with a decimal place or a fraction that is between 0 and 1, then it's going to be decreasing. It's going to be a decay. So that's what's going on. Since it's decreasing, it's by a factor, which is a multiplication, with every unit increase in x. So to the power of x. And basically, that's it. You're done with this question because you only wanted know to write it as an exponential function based on the formula. If we try to practice this one more time, the initial value of the function, so it's already telling you initial is 2. So let's start off with f of x is equal 2. That's your initial. Our factor, which is a multiplication, let's put in parentheses for that, it's 0.7. With every unit increase in x. Write an exponential function in the form of this that describes this situation. So technically, we could eliminate this. We have 0.7 as an exponent, and we have x not as an exponent. This is a linear. This is a linear function, so this is out, basically. If we observe that 0.7 is not your initial, so we're left with letter A, okay? Graph the function of y equals 3 times 0.5 to the power x, identify a y-intercept and isotopes. Again, we have gone over some examples from last time, 9.1. So if we're trying to graph this, we're gonna end up something like this. If you remember the information, your initial amount, which is your A, this is also your y-intercept. So y-intercept is gonna be 3, which is this part. Your isotope, again, if we look at the decay graph, is going to a positive values, positive infinity values on the x-axis, but it's never gonna be crossing. It's never gonna be crossing this line. It's gonna go all the way to infinity, but it's never gonna cross this line, which is your isotope at the y-axis at y equals 0. Your asymptote, I keep on saying that word wrong, isotope or asymptote. It's a very complicated word for me to say it. So asymptote is going to be at y equals 0. Again, this information, we've been practicing this in the past lesson in 9.1. So just go back and refresh and watch the video, some practice on problems. The graph of function f of x is 3 times 0.2 to the power x on a coordinate plane. Then identify the y-intercept and the asymptote. All right, let's look at A and B. Initial amount, your A, this is your y-intercept. So 3 is your y-intercept. It's not going at 4, so you could scratch out B. And by knowing that that's the only 2 options available, so the last option is A, which is y-intercept goes at 3, and the asymptote of the line is y equals 0 because it goes through here. This part is right here, the asymptote. This one at the 1, let's see, it could be correct. So this is wrong, this is correct because of this line. But you just gotta check all the information, okay? So that's basically concludes that lesson of 9.2 about growth factor and decay factors and certain graph. If you have any questions, please let me know. Thank you for watching. You have a great day. Thank you. Bye.